In this session, we are going to talk about 11th Physics, chapter number 4, Laws of Motion, part 4. First point is collisions. During collision, a number of objects come together, interact, that is, exert forces on each other and scatter in different directions. During a collision, the linear momentum of the entire system of the particles is always conserved as there is no external force acting on the system of particles. Let us consider figure for head-on collision as figure 4.3a before collision, figure 4.3b during impact, and figure 4.3c after collision, where m1 and m2 be the mass of spheres moving with initial velocities u1 and u2 respectively. After collision, moving with velocities v1 and v2 respectively. And during impact, force of interaction is F12 and F21, which are directed oppositely. However, the individual momenta of the particles change due to mutual forces, which are internal forces. Sum of initial linear momentum, which is equal to sum of final linear momentum. During any collision or explosion, where P's are the linear momenta of the particles. However, kinetic energy of the entire system may or may not conserve. Next point is elastic collision. A collision is said to be elastic if kinetic energy of the entire system is conserved during the collision along with the linear momentum. Thus, during an elastic collision, sum of initial kinetic energy is equal to sum of final kinetic energy. An elastic collision is impossible in daily life. However, in many situations, the interatomic or intermolecular collisions are considered to be elastic, like in kinetic theory of gases. Next point is inelastic collision. A collision is said to be inelastic if there is a loss in the kinetic energy during collision, but linear momentum is conserved. The loss in kinetic energy is either due to internal friction or vibrational motion of atoms causing heating effect. Thus, during an inelastic collision, sum of kinetic energy, that is initial kinetic energy, is greater than sum of final kinetic energy. During an explosion, energy is supplied internally. That is, sum of initial linear momentum is equal to sum of final linear momentum in elastic collisions or explosion also. Next point is perfectly inelastic collision. This is a special case of inelastic collisions. If colliding bodies join together after collision, it is called or said to be a perfectly inelastic collision. In other words, the colliding bodies have a common final velocity after a perfectly inelastic collision. Being an inelastic collision, obviously there is a loss in the kinetic energy of the system during a perfectly inelastic collision. In fact, the loss in the kinetic energy is maximum in perfectly inelastic collision. Next point is illustrations. First, Consider a bullet fired towards a block kept on a smooth surface. Collision between the bullet and the block will be elastic if the bullet rebounds with exactly the same initial speed and the block remains stationary. If the bullet gets embedded into the block and to move the jointly, it is perfectly inelastic collision. If the bullet rebounds with smaller speed or comes out of the block on the other side with the same speed, it is an inelastic or partially inelastic collision. Remember, there is nothing called partially inelastic. That is partially elastic collision. Elastic collisions are always perfectly elastic. An inelastic collision, however, may be partially or perfectly inelastic. On a hard surface, the entire system being in an evacuated space. If the ball rebounds exactly to the same height from where it. Second, visualize a ball drop from some height on a hard surface, the entire system being in an evacuated space. If the ball rebounds exactly to the same height from where it was dropped, the collision between the ball and the surface in turn with the earth is elastic. As you know, the ball never reaches the same initial height or a height greater than the initial height. Rebounding to smaller height refers to inelastic collision. Instead of a ball, if mud or clay is dropped, it sticks to the surface. This is perfectly inelastic collision. Now, we can explain elastic collisions and inelastic collisions with animation as
of elastic collisions. Examples of elastic collisions. 1. The collisions between atomic and subatomic particles, atomic nuclei, fundamental particles, etc. Inelastic collisions. The collisions in which only momentum of the system is conserved but kinetic energy is not conserved is called inelastic collision. Let us see the examples of elastic collisions. Examples of inelastic collisions. 1. Collision between cricket bat and ball. 2. Collision between two cars. Perfectly inelastic collision. When two bodies stick together after collision, the collision is said to be perfectly inelastic collision. In inelastic collisions, kinetic energy is not conserved. Example: the collisions between bullet and its target when the bullet remains embedded in the target is an example of perfectly inelastic collision. During these collisions, the loss of kinetic energy appear in the form of heat or as excitation energy, as in the case of atomic collisions. Perfectly inelastic collision. Let us consider a perfectly inelastic collision, that is, two particles of masses m1 and m2 have velocities u1 and u2 respectively before collision. After collision, they stick together and move with a common velocity v1. Then, according to the law of conservation of linear momentum, therefore, m1 u1 plus m2 u2 is equal to m1 plus m2 of v. Therefore, v is equal to m1 u1 plus m2 u2 by m1 plus m2. If the values of u1 and u2 are known, the final common velocity can be determined.
Thank you.